Chapter 7 Synoptic Climatology. For this chapter, we're going to talk about regional classifications, continental classification, hemispheric classifications, and lastly, modern applications of synoptic climatology. So the subfield of synoptic climatology involves the study of local, regional, continental, or hemispheric climatic conditions in the context of atmospheric circulation patterns defined by airflow or pressure fields. This chapter examines regional classifications, especially by the well-known classification of Hubert for the British Isles, but also the spatial synoptic classification that is applied at individual weather stations. It then considers the European North Atlantic scheme of gross Wetterlagen, large-scale weather patterns. Finally, two hemispheric classification developed in the former Soviet Union are discussed. The chapter examines the advantages and limitations of both subjective empirical approaches and objective numerical ones. It closes by giving examples of recent applications of synoptic climatology in evaluating the realism of the outputs of general circulation models and in accessing teleconnection patterns. Synoptic climatology is the study of climate from the perspective of the atmospheric circulation, with emphasis on the connections between regional daily circulation patterns and climatic conditions. This subfield developed during World War II, when efforts are made to predict weather conditions over Japan from patterns of airflow. Major texts on the subject have been written by Berry and Perry in 1973, Synoptic Climatology Methods and Applications, Berry and Charlton in 2001, Synoptic and Dynamic Climatology, and Yana in 1993, Synoptic Climatology in Environmental Analysis, a primer. The common approach is to determine distinct categories of synoptic weather patterns and then to access statistically the weather conditions associated with three patterns. A typical classification has about 20 to 30 types. The patterns may be based on isobaric or geopotential maps or airflow directions. The geographical scales involved range from regional to hemispheric until the 1970s. Classifications were developed subjectively. A skilled analyst looked at each day's weather map and assigned it to a type. Then, with the availability of digital files of pressure data and computers, numerical classification methods were developed. These range from correlation-based approaches where pairs of maps are correlated with one another, to empirical orthogonal functions, EOFs, or principal component analysis, where underlying patterns are extracted statistically, to self-organizing maps where artificial neural networks are used to group isobaric patterns into discrete types. A description of these approaches is provided by Berry and Charlton. A big advantage of objective numerical approaches is that the classification can easily be updated. A comparison and evaluation of various methods that have been applied for Europe is given by Hubert et al. There are several weaknesses involved in synoptic classifications. First, the atmosphere is continuous, so the determination of any boundary between circulation categories is arbitrary. Second, pressure systems are of varying intensity, affecting their characteristics, weather. Third, there are seasonal differences related to the changing intensity of the weather systems and contrasts in land-sea conditions that affect the air masses involved. Synoptic, in general, pertaining to or affording an overall view. In meteorology, this term has become somewhat specialized in referring to the use of meteorological data obtained simultaneously over a wide area for the purpose of representing a comprehensive and nearly instantaneous picture of the state of the atmosphere. Thus, to a meteorologist, synoptic takes on the additional connotation of simultaneously. A specific scale of atmospheric motion with a typical range of many hundreds of kilometers, including such phenomena as cyclones and tropical cyclones. Regional classification. The best known regional classification of synoptic circulation types is that developed by Hubert for the British Isles. For the surface, there are 8 directional airflow types: north, northeast, east, southeast, south, southwest, west, and northwest, each subdivided according to the curvature of the isobars: cyclonic, anticyclonic, or neutral, plus cyclonic and anticyclonic, giving 26 types in all. Originally, each day's weather map was categorized subjectively, but in the 1990s, an objective numerical approach was adopted. The original catalog of daily types extends from 1861 to 1997. The object catalog, based on method developed by Jenkinson and Collison, the UK Meteorological Office, in 1977, makes use of 3 basic variables that define the surface circulation features over the British Isles: the direction of the mean flow, the strength of the mean flow, and the relative vorticity. It extends from 1880 through the present, and it's available at this website, cru.uea.ac.uk. Recently, a new catalog has been developed using the same criteria, with reanalysis for 12 universal time coordinated from the new 20th century analysis, 20CR, for 1871 to 1947, and the National Center for Environmental Prediction, NCEP, from 1948 onwards by Jones et al. The 3 major types, cyclonic, anticyclonic, and westerlies, which comprise about 250 days per year, 68% of days, do not exhibit any major long-term trends, contrary to earlier conclusions based on the subjective classification of land. On an annual basis, the most frequent airflow type over the British Isles is westerly. It has a 35% frequency in December to January and is almost as frequent in July to September. The minimum occurs in May, 15%, when northerly and easterly types reach their maximum, about 10% each. Pure cyclonic patterns are most frequent, 13 to 17% in July to August, and anticyclonic patterns in June and September to 20%. Cyclonic patterns have a greater than 10% frequency in all months, and anticyclone patterns greater than 13%. The effects of changes in circulation type frequency versus within type changes of climatic characteristics was dominated by Perry and Berry for 4 stations in Great Britain between 1925 to 1935 and 1957 to 1967. Temperature changes in January were attributable to changes in the frequency of types, whereas changes in April, July, and October were linked to within-type changes in characteristics. The equation used to separate the two contributions to temperature changes is given in Berry and Carleton for the central United States. Coleman and Rogers developed a classification of 10 types using both surface and upper air data for 1948 to 2004. They first determined empirical orthogonal functions and then performed a clustering analysis to obtain the types. 3 types occur in both summer and winter, and 4 types in winter and the transition seasons. The annual frequencies of 2 winter synoptic types, associated respectively with strong zonal and meridional flow, are highly correlated with the phase of the Pacific North American teleconnection pattern, while eastern equatorial Pacific sea surface temperatures (SSTs) are linked to a synoptic type featuring low pressure around the Gulf Coast. Hubert was an English climatologist who founded the Climatic Research Union in 1972 in the School of Environmental Sciences at the University of East Anglia. Lamb was born in Bedford, England in 1913. Much of his professional life was spent in the UK Meteorological Office, where he worked on long-range forecasting, world climatology, and climatic change. He was one of the first climatologists to recognize that climate could change on human timescales. In 1950, he published his classification of British weather types and maintained a daily catalogue until his death in 1997. In the 1960s, he wrote a study on the medieval warm epoch and Little Ice Age based on historical documents and botanical evidence, and in 1970 he published a monograph on volcanoes and climate in which he proposed a dust veil index. In 1971, he left the Meteorological Office to become the first director of the Climatic Research Unit, established in 1972 at the University of East Anglia. He secured funding for insurance companies interested in climatic assessments of storms and floods. He published many notable papers and books on climatology and climate change. So, a description of the characteristics of the land types in Britain is given by Berry and Charlie. A summary of the climatic characteristics of the major types in the British Isles, called the weather types by Lamb. So you can see westerlies unsettled weather with variable wind directions as low pressure systems cross the country, mild and stormy in winter, cool and cloudy in summer.